This video is about our third core practical in Year 10, and it's the aim of the practical is to prepare a pure dry sample of copper sulfate. So that's the salt that we're going to produce, copper sulfate. And put the formula there as well, CuSO4. And we're going to produce that from an insoluble reactant. And the insoluble reactant is copper oxide. Okay, so the copper oxide is what we're going to start with, one of our reactants, and that is a solid. It will not dissolve in water, and that's important. And we're going to neutralize. We're going to do a neutralization reaction. We're going to neutralize sulfuric acid. So we're going to react sulfuric acid with the copper oxide, and that's going to produce the copper sulfate. It also produces water, copper sulfate. Now, copper sulfate is soluble, so that will be aqueous. And water, which is of course pure, so that's a liquid. Sulfuric acid also aqueous. So we have an insoluble reactant reacting with sulfuric acid, which is a solution, to make copper sulfate solution, and water. Now we want to prepare pure copper sulfate crystals, no sulfuric acid and no copper oxide and no water, just copper sulfate. That's the aim. So to do this, the most important thing is we are going to use an excess of copper oxide. An excess means too much. Okay, so we're going to use too much copper oxide, add some sulfuric acid, react it. We're going to warm it up. Why is it necessary to warm the sulfuric acid? To ensure all the sulfuric acid reacts. Okay, so we have too much copper oxide, an excess of copper oxide. So that's going to make sure there's enough copper oxide particles to react with sulfuric acid to ensure, and we're then going to warm it up to make sure all those sulfuric acid particles do react with the excess copper oxide to ensure all the sulfuric acid reacts. It also speeds the reaction up a little bit. Next question. Why is it essential to use an excess of copper oxide? Again, it's the same answer as last one, really, isn't it? To ensure all the sulfuric acid reacts. So once that happens, we've got excess copper oxide mixed with the copper sulfate and water. So we do need to separate that. Oh, this is quick answer. What does excess mean? Too much. So how is the excess copper oxide removed? We need a separating technique to remove an insoluble solid from a liquid, and that separating technique is filtration. So we filter out the excess reactant. What observations can you make of this reaction or during this reaction? Well, let's have a look as we start it off. So I've got my sulfuric acid here and my copper oxide, and we're going to react these. Now, it really doesn't matter. We're not doing this in a quantitative way, so it doesn't matter too much how much sulfuric acid we use, but I'm just going to put a little bit in the bottom there. And if we don't use everything, it doesn't matter. We're just trying to make some crystals. We're not trying to make an exact quantity. Now, we need an excess of copper oxide, so we need too much. So I'm going to put 3 spatches now, and that would be far too much. But that will ensure, hopefully, all of the sulfuric acid particles can react with some copper oxide. So we're going to give that a stir as well, because that's how we ensure reactions happen. We can speed up the reactions. What we're trying to do is get every last one of those sulfuric acid particles to react. Now, the question on the book before we started this was, what are our observations? Well, at the moment, it looks like it's turned black. That's only because we've put so much copper oxide in. So we'll see, hopefully we'll see some observations when we filter out or the copper oxide ore. In a moment, I'm going to put it into a water bath to warm it up to ensure all those sulfuric acid particles react as well. So we're going to transfer this now to a water bath. The water bath I've got set up on a Bunsen burner. I'm heating some water, so we will heat it in that water bath, and you'll see that in just a moment. So I don't need to use all everything from the beaker, because as I say, we're not doing this in an exact way. So I'm just going to put this into our water bath now, and that can heat there. So and we'll leave that for a minute or two to heat up and get warm. And hopefully as well, maybe we might see some of the copper oxide settling out, and we might start to see some observations of the reaction. If not, we'll filter it and we'll see more then. So the water was plenty hot enough in the beaker, so I've turned the Bunsen burner off, and you can see the copper oxide starting to settle out a little bit now, and we can start to see an observation that whereas we started with sulfuric acid, which was entirely colourless, and copper oxide, which was black, we can start to see now the copper oxide settling in that boiling tube, and the colour seems to have turned blue. Now, copper sulfate solution is blue, so that observation entirely matches the theory that we're expecting. Now we've finished heating the solution, to ensure all the sulfuric acid reacts to the copper oxide, it's time to filter to remove that excess, that unreacted copper oxide. So to do that, we need to filter it. We're going to filter it using a filter paper, and I'm just folding that filter paper now, and that's the traditional way to fold it. Fold it in half and into four, and open 1/4 of it like that, so when we look down, we see nothing but paper. We'll put that in a filter funnel, and we will take our solution and start filtering it. Now, I've left this settle for quite a while, so we're not going to pour too much copper oxide in there, but some will undoubtedly go into the filter paper. And the filter paper, if you remember, has got lots of tiny little holes in it. Those holes are certainly large enough to let the water molecules with the dissolved copper sulfate ions through the holes, but they're small enough to keep the copper oxide particles, the solid particles, behind. And we'll now leave that filter for a minute or two until we've got enough in there, enough pure copper sulfate solution in there. We've now finished that filtration, so we'll take the copper sulfate solution out of our flask there. We're going to pour it into an evaporating basin, because the last stage is to evaporate the water from that copper sulfate solution. So to do that, we're going to heat it on a water bath on a Bunsen burner. We're going to use a water bath because when you heat salt solutions like this, the water evaporates off to start with very nicely, but when they get quite concentrated, especially if you're heating them quite strongly, towards the end, they can start to spit out, and that can be a little bit dangerous. So if we heat it on a water bath, it's a bit more gentle. So I've got my water bath here. It's just a beaker of water on top of a Bunsen burner which we're heating up, and on top of that I'm going to put the evaporating basin with the copper sulfate. If I tilt that slightly, you might just be able to see the blue solution in there. So that's going to heat now, and the water in there will evaporate. It'll take some time, and maybe in about half hour or so we'll have some crystals, so we'll pause it. We'll pause the video and come back to us then. While that's evaporating away, I thought we'd just finish off the questions from the workbook about this core practical. So we got as far as this. What observations can we make of the reaction? The colourless solution, because the sulfuric acid started colourless, the colourless solution turned blue because the copper sulfate solution is blue. What is left after the copper oxide has been removed? Answer, copper sulfate. The copper sulfate was present, and water. Water was present too. How do we get just the salt? The salt is the copper sulfate, so we evaporate the water, and that's what's presently happening. What is the filtrate in this experiment? The filtrate is the copper sulfate solution, because the copper sulfate solution goes straight through the filter paper, therefore that's the filtrate. The residue, that's what's left in the filter paper, the copper oxide. What safety precautions should we carry out with this experiment and why? Well, safety specs, absolutely essential. Stand up, because we don't want to get burnt either, and if something tips over it might go on our lap. And leave apparatus to cool. That's important. So after that evaporation, it's all going to be very, very warm indeed. Why is a water bath used to evaporate the water from the copper sulfate solution instead of heating the evaporating basin directly with a Bunsen burner? When close to the finish, the salt can spit if it is heated too strongly. The water bath is a gentler way of heating it. Why should we not evaporate all of the water? For the reason I've just said. So the solution doesn't spit. Keeps it safer. It's safer. Okay, and I think it's probably about time that we had a look at what we've produced. So if I lift the camera up now and maybe over the top of what we've got there, then we're still evaporating away, but we're almost to the point of crystals. So I'm going to turn that off now and let it cool, and we'll have a look at what's left after that. And here's our final product. Just a teeny tiny bit of water left in the bottom of that will evaporate in time. But essentially in this evaporating basin we now have pure copper sulfate. Started with copper oxide, insoluble, reacts it with sulfuric acid. We filtered off the excess copper oxide, and that left us with copper sulfate and water, and we've evaporated the water to have pure copper sulfate crystals left.